Hello, so we've just done the 2x2 Anova and uncovered that we have a significant interaction. So here we have students who attended more than 50% of lectures seem to be scoring significantly higher in the SPSS exam scores when they had GCSE maths compared to those who did not have GCSE maths. And to continue this analysis, to unpick the interaction, we can perform what are called simple main effects. Now, the official way of doing this is to perform a one-way ANOVA. However, I like to perform an independent group's t.test because I think it gives a little bit more information, but I'm going to show you how to do it in both ways. So let's start by selecting just those participants who attended more than 50% of lectures. Now what we're going to do is compare their mean scores on the SPSS task based on whether they had GCSE maths or not. So the first thing we have to do is select just those participants, and we can do this in SPSS by selecting Data, Select Cases. Okay, so here we have a menu which I'm going to reset here. So what we're looking for is if condition is satisfied, we click this button here. If, okay, now we know the way that we've coded our variable, and for those participants who attended more than 50% of lectures, we coded them as 1. So we move the percentage of lectures variable across, click equal, and then 1. Continue, and then OK. Now, just to check that we've selected the correct group, if we go back to our data view, we can see all those participants who attended less than 50% of the time are actually crossed out. And that's what we want. We're only looking at participants who attended more than 50% of lectures, which is group 1. Okay, so let's go into the analysis. And this time what we're going to do is run an independent t-test. So to do that, we're going to analyse, compare means, independent t-test. We do the same as we've done before with the t-test, and basically the percentage on SPSS exam is our dependent variable, and what we're looking at is comparing the groups based on their numeracy, their GCSE maths. So to define groups, we know that we've coded them as 1 and 0, so we just tell SPSS what our codings are. Click continue, and then OK. If we look at our output, we can see the mean differences. Okay, this is just for the group that attended more than 50% of their lectures. If we look at the group sizes, they're roughly equal, just a few different, but that shouldn't make a difference with this analysis. We can see the GCSE maths score are significantly higher. We know they're significantly higher because our t-test value is less than 0.05. And what is interesting here is looking at the mean difference. So the difference between these two groups, the GCSE maths and no GCSE maths, is 26.31. So this appears to be the source of our interaction. Okay, so what we will do is compare the other group as well. So we'll compare GCSE maths, no GCSE maths on those participants that attended less than 50%. So what we're doing is comparing these two means here, less than 50%. The output we have now is representing the more than 50% group. So we have to go back and select the less than 50% group of participants. So to do that, we go into Data, select cases. It's always good practice to go back and deselect. In other words, select all cases. Okay. It's something I often forget to do, and if we do further analysis, we can usually end up in a bit of trouble if we've forgotten to do this. So go back and select all cases. But as we're actually looking at the alternative group, I'm going to, if condition is satisfied, and this time I'm going to swap it over to the less than 50% attendees. Click continue, click OK, and then go back to the output, and what we should see, the data view, and what we should see this time is that the ones are crossed out and the zeros are available for us to analyse. So what I'm going to do is the independent t-test again. So analyse, compare means, independent samples t-test. We've no need to change anything here at all because we're still comparing the maths group on our percentage on SPSS scores. So just by clicking OK, everything is in there as before. So let's look at the output for the low attenders, the people who attended less than 50%. Here we can see we have the means again, but look at the group sizes. There's quite a difference in group sizes there, which means, it's not a really good thing, and it's worth commenting on that. But the reason I like to do the independent samples t-test is because although here we can see we do have a p-value less than 0.05, in fact our p-value is 0.01, if we look at the mean difference is in this case 10.46, and in the previous example 26.31. So it's actually telling us quite a bit about the source of our interaction, which appears to be people who attend greater than 50% score significantly higher on the SPSS score than they do when they have GCSE maths than when they don't. And here we have a similar kind of story. However, the difference in the group sizes is a cause for concern, and this needs to be pointed out. Nevertheless, it shows that those two variables, attendance and the GCSE math score, are combined. In other words, they're interacting to create an effect in the dependent variable. What I'm going to do next is just show you the alternative and sometimes preferred way of doing a simple main effect, and that is doing a one-way ANOVA. So I'm going to select the people who attended greater than 50% of the time again, just to show you this one example. Click continue and OK. I'm going to double check that I've selected the correct one. So the zeros are crossed out, and the ones, the category who attended greater than 50% of the time, are available for the analysis. So I've selected the correct group. So what I'm going to do is a one-way ANOVA. So analyse, compare means, one-way ANOVA. And remember our factor, what we're comparing is our GCSE maths, whether they had GCSE maths or not, and our dependent variable is percentages on the SPSS score. I can also select descriptive statistics as well. That will give me the means output. I do have to select it in this case. In the t-test example I didn't, it was automatically produced. So this is the one-way ANOVA, which is effectively the same, approximately the same as an independent t-test. So I click OK, and here is my output for my one-way ANOVA. And here we can see we've got our means. So the means are the same. Difference here with as we had with the t-test example. And as we can see, our ANOVA table is telling us that these groups are significantly different. So again, selecting that group is telling us that our interaction is at where students attend greater than 50% of the time and they have GCSE maths, they're scoring significantly higher, which is this group here, 74.79, than the no GCSE maths group, which score 48.48. So that's how to do a simple main effect, and it just kind of adds a little bit of a postscript to an interaction. It's a way of unpicking the interaction and reporting where the significance lies, not only visually with the graph, but statistically by looking at either the t.test, which is my preference because it gives you the mean difference of the scores, so you can make comparisons. But what is concerning about the less than 50% attenders, although the difference was significant, the group sizes are unequal, which is a cause for concern. So you can report these in your results and come to some conclusion. Okay, thank you.